Now you can go sharing, and I will start admitting people, okay? We're okay to go.
Okay, hello everybody and welcome to this edition of Astronomy on Tap that we're doing slightly different to before. Thank you all for joining us. It's great to have you with us in a slightly more closer format than just via YouTube. So we hope you enjoy a chance to be a little bit more interactive tonight than usual. So we have a very exciting program. All about the Earth, since last week, was it Thursday, was Earth Day, which is a celebration of the Earth. It is the only planet we have that we can live on, so we want to look after it. So we have two excellent talks today on that topic. Just a brief introduction for those of you who don't know, Astronomy on Tap has been going for a number of years now. It started in 2013. In New York City, and then has spread throughout the world with over 40 locations across the world. Here at Astronomy on Tap Leiden, we've been running since March of 2017, so just over 4 years. Last month, we celebrated our 4th year anniversary. To advertise, we're on social media. I'm sure you will have seen this as you found the event tonight. Yeah, if you want to leave a remark in the Zoom chat here, tell us where you're watching from. This is also streaming on YouTube, so if there's anybody there watching, you can also say hi there. And we will also be able to take questions. If you want, you can leave your questions, write them out in the Zoom chat, and we'll have a moderator ask them, or you can virtually raise your hand to ask questions during the talk. First up, we have a little bit of astronomy news. I found 3 different things in recent news this month. One exciting thing is that the Hubble Space Telescope has been celebrating 31 years of observations orbiting the Earth. It's observed about 48,000 different objects with 1.5 million observations over its 31-year history. You know, it didn't start out quite so well as planned, but it very quickly got up on its feet and got going. We're also very excited this year to watch the launch of the James Webb Space Telescope, the next step. Another very exciting thing in space news was the flight of the Ingenuity helicopter on Mars, carried there by Perseverance. So last week it made its first flight on a different planet. And another really exciting thing was the observation of this really, really powerful flare from the Proxima Centauri star, which is the nearest star to the Earth, and in fact has a planet around it. But this flare was about 100 times more powerful than any flare ever seen on the sun, and it's been observed at multiple different wavelengths. And this kind of has consequences for what we would hope to have life on other planets, but if they live around a star that is so active, it has consequences for the life on that planet. So just to give you a rundown of what tonight's program will look like, we have 2 talks, first by Gina Mathe, then we'll have our quiz, and because we're in Zoom tonight, you should be able to follow along the quiz. It will be on an online service, but there's no delay now that we usually have between Zoom and YouTube. Then we'll have a brief moment if you need to stretch your legs or get another drink. Then we'll follow with our second talk by Violette Impellizzeri, sorry, with our second talk. So without further ado, our first speaker is Gina Mathe. Gina has been a passionate advocate for the planet Earth. She studied in Scotland. She did her PhD in environmental science. Then she worked in the Americas doing environmental communication. And now she's working in the Netherlands. She works at European Radio Astronomy Institute as a science communication officer. And she's been one of the founding members of Astronomers for Planet Earth, which she should hopefully tell us a bit more about. A really interesting fact about Gina is that she spent a year living outside and has written a book. So this is the Wiltjaar in Dutch, presumably. So she's going to be talking tonight about the so-called planetary boundaries, so sort of limits to resources on the planet Earth, and hopefully how we can avoid having a journey on a sinking ship. So I will hand over to you now, Gina.
Hey, thank you, Dee. Yeah, I'm just going to point out quickly that I did not write the book. I wish I had. But that was written by my husband, and we actually spent a year together living outside. So it was very much part of the experiment, but my Dutch is not quite up to scratch yet to warrant writing a book. But without further ado, ahoy my hearties, and welcome to Planetary Boundaries for Landlubbers. Now, firstly, I would like to point out this talk, were it not for COVID, would be taking place in a wonderful establishment that provides drinks for all tastes. And so I hope, like me, you have a drink at hand. And it is at this point that I would like to introduce you to the first and only rule of the evening. Any pirate references that are made during the course of the talk should cause your drink to move from your hand to your mouth to keep things merry on board. So slug a grog and have a drink. And now that that rule is cast, let's set sail. I will be your co-captain for the evening. And for those of you who don't know me, my name is Gina Mathe, but that's captain to all of you. And I have spent the best part of my life finding different ways to understand the natural world. After training for a PhD in environmental science, I worked in research and environmental communication before jumping ship to join the astronomy crew as a communications officer in radio astronomy. And in that moment, my appreciation of the natural world went stellar. It also led me to attend the European Astronomical Society conference in Lyon in 2019, where a fortuitous meeting of like-minded individuals, including Violetta, resulted in the establishment of the European arm of Astronomers for Planet Earth. And Violetta is going to tell you a bit more about that in her talk. Before she does that though, and in appreciation of Earth Day, we're going to take a look at how we understand the limits of human existence on our very own pale blue. So we're going to go back to 2009, when a group of researchers gathered, as researchers do, around a cup of coffee to discuss ideas about sustainability. And they came up with this idea of a safe space for humanity to operate, or planetary boundaries. And yo ho ho and a bottle of rum, they devised 9 quantifiable environmental boundaries that regulate the stability and resilience of the Earth system. The concept is basically a question of how much stress can humanity exert on the planet while ensuring our own species' continuation. So let's drop anchor for a moment and take a quick look at the 9 boundaries. Now, this is them mapped out in a lovely circular diagram. The diagram splits into 3 parts. In green, here in the middle, we have the safe operating zone. Around that, in yellow, is the zone of uncertainty, And finally, in the outer part in orange, the rather ominous beyond the zone of uncertainty. Now, while we look at these boundaries, which was last updated in 2015, I thought we could play a game. Now, as we look at each boundary, I want you to guess how we're doing. Now, for this, you can shout, but as I can't hear you, you can also do an action, but as I can't see all of you, unfortunately, I'm just going to hope that you're doing it. So if you think we're all good and green in the safe operating zone, then I would like you to say, "Arr." If you think we're in the zone of uncertainty, I would like you to say, "Nay." If we're all the way out beyond the zone of uncertainty, then please shout, "Bildrat." And if we don't have enough data yet, or you think that it's inconclusive, then shout, "Alas." So again, if we're in the safe operating zone, "Arr." If we're in the zone of uncertainty, "Nay." If we're way out beyond the zone of uncertainty, shout, "Bildrat." And if we don't have enough data yet, or if we haven't quite worked things out, then please shout, "Alas." This is going to be a great game because for me, it's just me shouting at myself. But I hope you're paying attention because I'm going to remove the diagram to make it just that little bit harder. And the drinking rules do still apply here. So I can't hear you shout, so please shout as loud as you like to your heart's content, and extra points if your neighbours ask what you are up to. So first up, we have climate change, probably the one we're all most familiar with. Now, this boundary is the concentration of greenhouse gases present in our atmosphere. Obviously, carbon dioxide is the captain here. So guesses, we're going to go with nay. We passed 350 carbon dioxide parts per million in 1988. That was our safe operating zone. At over 400 parts per million, we are now well and truly operating in the zone of uncertainty. Now, novel entities. This refers to chemicals and substances that are released through human activity. So this is where you'll find your plastic pollution, as well as radioactive materials, all of these things lumped in together. Now, guesses? Alas, this is an incredibly complex boundary, and we release so many substances into the environment every day without truly understanding the consequences. Stratospheric ozone depletion. This is where you find your holes in the ozone layer, and how are we doing? Well, thanks to the 1987 Montreal Protocol on substances that deplete the ozone layer, we've actually had collective impact on reversing this sorry situation. So well done, team. Thumbs up to us. Atmospheric aerosol loading. Aerosols are fine, solid particles, liquid droplets, or gases suspended in the air. And these can be something natural like fog, for example, or something that is human-induced. We know that aerosols have an impact on human health and also on environmental cycles like monsoons, but they are extremely difficult to quantify. So, alas, we're not sure where we're operating yet. Number 5, ocean acidification. Increasing levels of carbon dioxide also contribute to increasing acidity of the world's oceans. What happens here is carbon dioxide that is absorbed into the ocean forms carbonic acid. And this is bad as it means that carbonate ions are no longer available for many species that rely on them as building blocks, species such as coral. Now, for ocean acidification, we're operating in the safe zone. However, this boundary is so closely tied to the concentration of carbon dioxide in the atmosphere that it really should be a nay. Oh, biogeochemical flows. Through changing industrial and agricultural practices, we have been applying fertilizers far too readily. Nitrogen and phosphorus are important for plant growth, but most of what we apply ends up leaching into our aquatic systems and causing complete havoc. And because of that, my hearties, this is our first build rats. We are in big trouble here and operating way beyond the zone of uncertainty. Freshwater use, again, our industrial and agricultural practices place a huge demand on freshwater use. At the moment, this one is an R. But it is also closely linked to climate change, which increases the stress on the boundary with periods of drought and flooding and disrupted weather cycles. Number 8, land system change. We've been readily converting forests, grasslands, wetlands, you name it, into agricultural areas all over the world. This has a huge impact on ecosystem quality, function, and distribution. So it is a hard nay. Land system change, in turn, acts on our final boundary, biosphere integrity. Now, this is a bonus, as this boundary actually splits into two: biodiversity intactness and extinction rate. Now, for biodiversity, we're looking at how intact ecosystems are by measuring their diversity, and alas, this is difficult to quantify at the moment, but come on, we know that it is bad, really bad. And extinction rate is calculated by the number of extinctions per million species, which build rats were actually living through the 6th mass extinction our planet has been through. So to summarize all of this, basically, we're sitting on the poop deck. I mean, actually, we've walked the plank off the poop deck and we're out swimming with sharks. I mean, although not as many are around as there should be, which may be one of the only bonuses of climate change. So now I hear you. I know what you're thinking. You're going to say, Gina, you scallywag, this is it. I'm stopping with astronomy and becoming a conservationist. Except these boundaries themselves do not exist in isolation. They are merely a projection of our impact that is a result of how our cultures and societies act. The desperate situation we are in should be at the foundation of every decision we're making at the moment. And that is why we're all in it together. Tackling climate change, biodiversity loss, land system change all require collective action. A consideration of resource use and impact should be part and parcel of how research in every discipline is conducted. Excuse me. And astronomy gives a great way to understand our planet in its entirety. And with that, movements like Astronomers for Planet Earth should be both applauded and joined. And that's what Violette is going to talk to you a bit more about, along with some very interesting things on black holes. But just before Violette does tell you more about this, I know there is one pressing question still to be answered. Why are we dressed as pirates? Well, to answer that, this is primarily due to this man. This is Professor Pete Smith. He is a lead author on the International Panel on Climate Change and someone that I was lucky enough to be lectured by as an enthusiastic master's student. While he's a heavyweight in climate research, this photo was actually taken when he was admitted to the Royal Society of Biology. He is also a fantastic communicator. And it was during a talk in a pub, very much like this one, that I learned more about climate change and environmental impact than in any lecture I've ever been to. And at the time, he also happened to be dressed as a pirate. Wendy, shall I pass it back to you?
Oh, thanks, Gina. We'll now take questions. So Lemim will moderate our questions.
Yeah, well, sorry, I was still waiting. Yeah, so that was fantastic, Gina. I loved your talk and I love this little bird that you have on your right. Yeah, so so now we'll be taking questions. So today we're going to do something different than usual, so our audience can directly ask questions to the speaker. So if you will be, you are willing to ask your question, please raise your hand using the reaction button in Zoom. And we will, I will then ask you to unmute, in order. However, if you ask this question on Zoom, it will be on YouTube, so you'll be on live. If you do not want to do that, you can also ask your question right in the chat and I can read it out for you. So yeah, feel free to ask the questions, but while we are, so we just have the comment from Violette that love the pirate story. I could actually find a picture of him dressed as a pirate. Yeah, maybe it would be something nice to add to our event media afterwards. So as like a starter question, what could be something astronomers can do to join in the pirate troop?
Yeah, we should really start a pirate troop, I think. I think one of the things that can be done is obviously joining Astronomers for Planet Earth is a growing movement. And there is now a petition that was released on Earth Day that you can sign to make sustainability a primary goal in astronomy. But I think the key thing is making sure that you find connection every day. So as I said, astronomy is part and parcel of the big picture, and questioning how astronomy is conducted, questioning what ways we can change practices. It can be small, but these things can snowball into much bigger actions.
Definitely. Thank you for answering that question.
Thanks. I do see Leo's just put a link to the letter in the chat. So yeah, if you haven't signed it already and you are an astronomer, please do so.
Yep, and we actually have one question from Ishan Mishra in the chat that he did not catch the name of the professor who tested as a pirate. So what was his name again?
Yeah, this is Professor Pete Smith, Peter Smith officially. And he's actually, he's a soil scientist at the University of Aberdeen, but he has a huge knowledge on climate change.
Okay, I hope that answers the question. We have actually one raised hand from the audience. Tuan Ant, I will ask you to unmute. Yeah, I think you can, talk now.
Hello, thank you for the talk, very interesting. Can you hear me, first of all?
Yeah.
Yes, great. My question is, so you mentioned that the initiative is to make astronomy more sustainable. Can you give like one or two concrete examples of how you can, how you make astronomy more, as a field, more environmentally friendly and more sustainable? Is it something to do with the energy consumption of your instruments? Or?
Yeah, it's a really, really good question, and you have hit the nail on the head. So this is a lot of, we're actually discussing these topics a lot through Astronomers for Planet Earth, but energy use is somewhere that there is definitely room for improvement. At the moment, there is a lot of interest focused on institutional energy use, but operational use is also a really important topic. So how we power the instruments that we're using in astronomical observations. And I think there's a huge, there's room there for a huge amount of improvement. And when I, as a sort of a slight outsider looking in, when I look at what astronomers are able to achieve, and the ingenuity that is there among the discipline, I really think that it is a discipline that can take this forward and be a lead.
Thank you.
Thank you for your question and the answer. We have one question from our YouTube viewers. So Andrew Reitmeier wrote for Gina, is there international political and scientific agreement on how the boundaries are defined?
Yes and no. And I would say, so this research is led by the Stockholm Research Institute. And the original paper on this was published in Nature in 2009. And it has been used as the groundwork for a lot of sustainable thinking that has followed. So, for example, there is a lot of interest now in the work of Kate Raworth, who's an economist, who used the environmental boundaries to build a new economical model for humanity to work in. And places like cities like Amsterdam are now adopting the economic model that she developed based on this to look at changing their practices going forward. It has been used a lot in UN documentation as well, but in terms of true policy take-up internationally, we're not quite there yet.
Okay, that's I think that answers that question pretty well. And we have our last question from Abhijit Borkar. It's what's the effect of climate change on piracy?
Well, if we're looking at sea level rise, then maybe it's an opportunity for pirates to make a comeback. But I think, you know, if you delve into the Pirates Code, pirates are they're all in this together, and they are all in for sharing the workload. So in that sense, I think pirates are ones who will happily take up the message of climate change and club together to address the topic.
Yep, definitely. We are all in this together. So thank you, Gina, for answering all these questions and the excellent talk. And thank you to our audience. Actually, we have one additional question. Do we have time for this? Or perhaps if you can go through the chat and answer the questions. So to the audience, again, if you have more questions, feel free to write in our Zoom chat here, or you can also write in the YouTube and we'll make sure that it goes to the speaker. And with that, we move on to the gates, and I give the floor to Anik.
Yes, thank you very much. We are very excited to test out this new game format with you tonight. So I hope you can see this. So tonight we're gonna do the games a little bit differently. We're gonna use this website called Mentimeter. So to participate in the games, get out your phones or your iPad or even your laptop works and go to menti.com. It's here written on the top, and use this code. So you can see this still when I move to some other things. All right, so can you either use your phone, tablet, or laptop to play? And one important thing is in a little bit, you can register your name to participate in the game. And because we always have an astronomer and a non-astronomer winner for the game, we ask you if you have an astronomer in your team or if you are an astronomer, please sign up your name with an _A behind your name. Then we know who the astronomers are. And also answering faster will earn you more points. So this actually is quite a game of quickness too. So we're quickly gonna move first to the signing up. So you should be able to sign up your names now. I see a lot of people have joined already. That is really great. I'll give you one more second to sign up. I also love all the emojis. There's very, very cute ones in there. And I think you should be able to join any moment at menti.com, just using the code on the top of the slide. All right. Then I'm gonna go explain the first game that we're gonna play tonight. And the first game is called Sizing Up the Universe. So the question is, can you correctly guess the relative size of these objects? So an example question could be, if the Earth was the size of a Brussels sprout, what size would the moon be? And then the answer would be, the moon would be the size of a blueberry. Right? Okay, let's go. The first question, if the Earth was the size of a basketball, what size would the moon be? Would it be a tennis ball or a volleyball? Only 1 second left. Time's up. Let's see how you did. Wow, 26 of you got it correct. I'm very impressed. But of course, this was an easy question to start out with. So let's see our scoreboard. So the faster you answer, the more points you get. Oh wow, is here all really close to each other. That's great. All right, so for the next 2 questions, we need to look at the planets in our solar system. So this image that you see right here are the planets in our solar system, and the sizes are to scale. The distance between them are not, but the sizes are. So take a quick look at these different planets and our sun, so you can answer the following question. If the Earth was the size of a basketball, what size would Jupiter be? Would it be a car or a bus? Time's up. And most of you were thinking bus, but actually the right answer is a car. Who thought? Let's see what this does to our scoreboard. We can see some differences appearing now. Number 1 is now, well, it's actually still pretty tight. So we're gonna go to the next question. And the next question is, if the Earth was the size of a basketball, what size would Saturn's rings be? Would it be the size of a football field or the length of a bowling lane? Oh, still pretty divided. Oh, and this time most people had it correct. It was indeed a bowling lane. Very well done. We're changing the top 3 again. That's great. All right, the next 2 questions are about stellar evolution. So as you can see here in the picture, we can make a distinction between small stars and large stars. And both of these stars, when they enter lives, they swell up and they become red giants. Or actually a small star becomes a red giant and a large star becomes what we call a red supergiant. And when this large star, when it dies at the end of its life, and then it explodes into a supernova explosion, and depending on the mass of the star, it either becomes a neutron star or a black hole. And for a small star, it also becomes a red giant, but it's not heavy enough to explode into a supernova. So at the end of its life, it sheds its outer layers and it makes a beautiful planetary nebula. And the star itself becomes a white dwarf remnant. So this is what happens to these stars. And these images are actually not to scale. So you're gonna have to be very clever to know these next few questions. So question number 4. If the sun was the size of a basketball, what size would a red giant be? Would it be the size of a car or the Hollywood sign? That's great. Most of you got it correct. Indeed, the size of a Hollywood sign. So the red giant star is really large compared to the sun. And actually our sun is gonna also become a red giant star at some point. Then it's gonna become really big. And this is our scoreboard. We can see it changing. You can, by the way, also see who was fastest in each question. Here I see Travis was fastest. All right, then question number 5. If a red giant star was the size of a pumpkin, what size would a planetary nebula be? Would it be a tall mountain or a train? Let's see. And the correct answer was tall mountain. Again, most of you got it correct. Well done. Let's see what this does. Oh, look at this. Our top 3 is shifting. Nice. And then, oh, yeah. If the sun was the size of a swimming pool, what size would a neutron star be? Would it have the thickness of a sheet of paper, or would it have the size of an atom? Yes, nicely done. So 20 people had a correct thickness of a sheet of paper. So actually most neutron stars have around a size of 10 kilometers. So that's pretty small compared to the moon, only 10 kilometers. And this is our leaderboard. Again, we see some shift happening. Wow, the number 1 is already up at 5,000 points. It's very impressive. And then the next few questions of this game is going to be about galaxies. So here we see a picture of stars in our own Milky Way. And here this blob that you see on the right, that's the Large Magellanic Cloud. And here on the left is the Small Magellanic Cloud. And these are 2 dwarf galaxies that are orbiting our own Milky Way. So take a glance at them, see how they look. And then we're going to go to the next question. Question number 7. If the Small Magellanic Cloud was the size of a person, what size would the Large Magellanic Cloud be? The size of a car or the size of the Eiffel Tower? Ooh, we have almost a split here. And the correct answer is car. Actually, myself, I also would have guessed the Eiffel Tower. But yeah, the size of a car. So actually, the Large Magellanic Cloud, it's quite a bit bigger than a Small Magellanic Cloud, but not that much. So this must give some changes in our leaderboard here. There we go. But still, Ishan is leading. Well done. And then the next question. If the Large Magellanic Cloud was the size of a car, what size would the Milky Way be? The size of a helicopter or an airplane? So this is a tricky one. All right, and the correct answer was airplane. Very well done. And that's our leaderboard right here. And this was the final question of the first game. But luckily, we still have another game to go. So don't despair yet. You can still come up higher on our leaderboard. And game 2 is going to be presented by Stella.
Hello, everybody. Let me see. Cool. So the second game today is going to be Earth from above. So in this game, I will show you images or videos taken by satellites of Earth. So it's Earth observing satellites. And I will ask some questions about these images. And I think without further ado, we can start the start the first question. So what caused this fluctuation in levels of nitrogen dioxide across these 3 years? Heavy rainfalls in February 2020, COVID lockdown and later reopening, a ban on diesel trucks and later lift-off ban. In this game, you will have more time than the previous one because it's a little bit more lengthy question, so take your time, or not, because it will cost you points. Oh, yeah, everybody almost got it right. So indeed, it was related to a coronavirus lockdowns in early 2020. When lockdown started, the pollution levels severely dropped because there were fewer factories that worked and traffic was also much less. Now that the restrictions have started to be loosened a little, these levels of pollution and nitrogen dioxide in particular have started to rise up again, and they are returning basically to pre-COVID levels. While the pictures showed only a region of China, this trend has been seen worldwide. Let's see the leaderboard then. Wow, okay. Everything keeps on changing again. I think this is going to be the trend until the very end. Let's go to the second question. So what are we seeing in this image here? Is it 1, the Suez Canal traffic jam, 2, stars reflected from the sea surface, or 3, plastic pollution in the Red Sea? What could it be? All right. Quite a variety of answers, but still most people got it correct. So it is indeed the Suez Canal traffic jam after the container ship got stuck in the canal. If you go to the next slide, Annick, yeah, you can see the before and after pictures here. So on the left-hand side, you see that the boats are going up or ships are going up the canal happily, whereas on the right-hand side, you see a ship stuck in the canal, which is pointed with the Ever Given tag, and also the ships accumulating in the Gulf below. Okay, next question. Oh, first the leaderboard. Yes, I forgot about that. First the leaderboard. This is great to see. We still have a very strong leader though. Let's see. Okay, next question. So what happened between the before and after pictures that are shown here? Is it 1, onset of hurricane season, 2, a forest fire, or 3, a volcanic eruption? All right, let's see. Oh, that's much more evenly distributed now, but yes, the volcanic eruption is the correct answer. So these images show the aftermath of a volcanic eruption that just happened a couple of weeks ago on the 9th of April in St. Vincent Island. So around 16,000 people have been evacuated due to the ash that has come from the volcano after the eruption. And this is also an example of how space satellites can help with these cases. For example, in response to this event, the Copernicus Emergency Mapping Service was activated, and these services really help to coordinate the response for these disasters and help organizations make the effort to better respond to these kinds of natural disasters. All right, let's see the leaderboard again. Ooh, some changes here again. Okay. We have a couple more questions, so let's see how different the end game will be. So what are these dark patches shown here with the question mark pointing at them? Is it 1, penguin poop, 2, chemical spill, or 3, rising smoke? What could it be? Okay, let's see. Yes, so the answer is indeed penguin poop. And this is actually funny because scientists actually use the satellite images of penguin poop to monitor the presence of penguins and possibly discover their new colonies. Although penguins are too small to be seen from satellite images, the penguin droppings actually are visible. So this is what scientists use to track them. Let's see now the ever-changing leaderboard.
Ooh.
I feel like the first 3 people are very set now in their winning streak. All right, next question. What is being tracked in this video here? Is it 1, dust from the Sahara Desert, 2, nitrogen dioxide from Northeast Africa, or 3, pollen from Central African rainforests? All right. Oh, most people got it right. Good job. So yes, it is indeed dust from the Sahara Desert. And every summer, the wind carries the large amounts of dust from Sahara Desert in North Africa towards the Americas across the Atlantic Ocean. This particular event that we were showing here happened in June 2020. And although in general, this event is not so special, the particular event that happened in 2020 was indeed unusual because of the large amounts of dust that it carried, and also because of the crazy distance that it traveled. Even though it might be a little counterintuitive, the dust plumes that come from Sahara are actually really important for our ecosystem. And there are multiple reasons for that. For example, if the dust falls on the ocean, this gives nutrients to the plankton, which are also nutrients for many different marine life. Also, the dust is very necessary for the life in Amazon rainforests because it provides nutrition that is otherwise depleted from the soil due to the heavy rainfall that they have. And finally, also the dust clouds have been shown to stop the development of hurricanes and storms in the Atlantic because they give this dry and dusty air, which then prevents the storms from developing. All right, after all this talk, let's go and see the leaderboard. Nice. The leading trio standing strong. Are they uncatchable by this point? Maybe. If you hear anything in the background, that's my cat doing crazy things. All right, next question. Which cities are these? So the options are Amsterdam, Venice, and Stockholm. And the top one goes with 1, the second one with Venice, with 2, and the bottom one with 3. So take your best guess. Nice. Almost everybody got it right again. Indeed, the first of these images was Amsterdam, the middle one Venice, which I almost spoiled, well, I did spoil. And the third one, and the bottom one was Stockholm. Now, let's see the leaderboard. Oh, everybody here in the top got it right. And there was a change in the top. Wow. So this very last question, will it make a difference? Let's see. What is shown in this picture? Is it A, row of crops, B, solar farm, or 3, real panda bears from space? Nobody guessed real panda bears? I'm surprised. Okay, let's see the leaderboard. But yes, it is a solar farm that is based in China. Congratulations!
Awesome. We have our winner for this game, which is Ruben. So applause for you, Ruben. And I always find it great to see that the winner is a non-astronomer. So
yes,
very well done. So the winners for our evening are actually Ruben and then the astronomer, Ishan, number 2. So thanks everyone for playing. And
congratulations to everybody as well who played.
Yes, I really hope you all like this new way of doing the games. And for Ishan and Ruben, please send an email to astronomyontap@leiden@gmail.com. Give us your address and we'll send you your gift. So thank you so much for playing again and hope to see you again next time. And we'll have a short break now before the next talk. So I think we'll be back in 5 minutes.
Yes, we'll be back in 5 minutes. Okay, so welcome back. Sorry about my video. I'm merging into the background, but that's okay. We will continue now with our second speaker. I think that's also the first time we've had penguin poop as an answer to one of our quiz questions, which is most fun. So our second speaker, I will get this up in a moment, is Violette Impellizzeri. Again, sorry, Violetta, for pronouncing your name incorrectly. So Violetta is an astronomer. She works on black holes mostly. She really likes observations, particularly observing the sky at night. She studies black holes, how they grow, the jets that come out from them. And in particular, recently, she was part of the team that produced that amazing image of the black hole in M87. She first encountered climate change early in her career, but it seemed much a thing for climatologists, and so she pursued astronomy. And more recently, she's come to realize that these two are very closely entwined, and there are in fact ways that studying black holes can help us to solve the climate crisis. So looking forward to hear more about that. And she has lived in 6 countries across 3 different continents, but since she moved to Leiden quite recently, she's fallen in love with these beautiful tulip fields that we have in the surrounds of Leiden. So Violetta, over to you.
Thank you, Wendy. I'm going to share my slides. All right. Okay. Oh, I'm having an issue here. Moving. Okay. All right. Thank you for those who are still with us and still filling their beers. I'm very excited to be here tonight talking to you. As Wendy just said, I recently moved to Leiden only in August, so not even a year. Before coming here, I was actually living in Chile for almost 10 years. I'm going to tell you a little bit more about that in a minute. So I'm going to talk about climate change, even though I'm an astronomer, but I would like to start by telling you first about my astronomy interests. And let me just first start telling you that I'm interested in galaxy. This is a beautiful image of a galaxy, of a spiral galaxy taken by Hubble. And I like, I'm interested in seeing how the galaxies form and evolve over time. But in particular, there's a special subset of galaxy that really catches my attention. And these are galaxies called active. And we think of them as active because they know there's something happening in the very core, for which we also see jets that are ejecting, and they far exceed the galaxy. So this is another galaxy called Centaurus A. You can see the optical here in the center. And then if you look in the radio regime, a much shorter wavelengths, you actually see those jets moving really far beyond the galaxy. And they seem to come from the very, very core. There's more examples of active galaxies. This is another very famous one. It's called Cygnus A. It's one of the brightest radio sources in the sky. And again, from the very central part component, there's these huge jets going really far into intergalactic space. And again, if you look even closer, you see these jets actually are really narrow and very streamed all the way to the center. And in blue, you see here, there's even X-ray emission visible. It's very powerful stuff. There's another, here's another very famous active galaxy. I think all of you have heard of it by now. It's M87. This active galaxy has a jet so powerful that we can actually even see it in the optical. And also the spectacular jets are also seen in the radio again. So again, a shorter wavelength. And here from the left, you see the jets sort of far out, zooming out. You see their impact on the environment. And then as you move further and further to the right, you actually zoom further and further in. And you see the jets continue all the way to the center, and they become narrow stream, for which they're coming from a single point. And all the way to the right, we see we're getting closer to where the jets are actually being ejected, but we're not really nearly there yet. There's something missing. However, we do know that that is the origin, and what people think, and I think you'll know, is that at the center there's probably a black hole, and it is the black hole, that dot at the center, that is making these really humongous ejections. How are jets created? We don't really know yet. And can we see the black hole at the center? In order to find out whether we could see it or not, astronomers have been building bigger and bigger telescopes. We still are building bigger and bigger telescopes. But there is a limit to how big you can make a telescope, right? At some point, it's going to fall over. So one of the ways, smart ways astronomers have to observe, smaller and smaller things in the sky, is to use interferometry. That is, you observe using very many telescopes that already exist, but you observe them at the same time, and then you combine the data afterwards, and it results in one telescope as big as the distance between them. And that is exactly what the Event Horizon Telescope did, and is doing still to date. And that is what resulted in the very first image of a black hole. Ta-da! Here it was. That technique worked, and it took many years to actually happen. I'm going to leave the realm of black hole for a moment now, and I'm going to come back right at the end when we talk about solutions, because now I would like to tell you a little bit more about climate change. So why am I here talking to you about climate change instead of continuing my black hole story? For this, I need to take you back to ALMA. ALMA is a big telescope, big international collaboration, which is situated in Chile. And this is where I spent the last 10 years before coming to Leiden. I actually joined in August 2011. This is a picture of me having recently arrived. The telescope at the time was still in construction. There were about 12 antennas when I arrived, and the 12 antennas were at 5,000 meters. They still are 5,000 meters. Actually, this is where this antenna was taken. This is me, my expression, lack of oxygen, basically, about to faint. There were about 12 antennas at the time, and now there are 66. So it was a very busy time and really exciting. There was construction ongoing, and we became part of that team that was constructing and commissioning this amazing telescope. Here's a picture of actually the 2017 observations that we did for the Event Horizon Telescope. And on the left is our colleague Chirioko Godi, who is actually in Leiden at the time. The telescope is an international collaboration, and it was put in Chile because it is the driest desert on Earth. Well, most of the time it is. Sometimes it does rain. Actually, I think this picture here I took also 2017. And actually, we have noticed that some extreme weather events and storms are becoming more common from when the site was picked about 20 years ago. But this is not always the case. In fact, it is usually the case that Alma and the Atacama Desert is a really, really, really sunny place, and it's really, really hot. So when I arrived there, one of the things I noticed right away, it was in construction, is why aren't there solar panels? Why aren't we operating with solar panels? Why are we using turbines? If you look in this picture, actually, if you look closely, what is this? These are turbines that we use for running our telescope. And we use gas or diesel, and often it causes actually even blackouts. That was really true at the beginning of the commissioning phase. This happened very regularly, and this is a picture of us getting bored at night, not knowing what to do while the telescope was out. I remember during this time going to some of the management, the people constructing, some of the people in charge, and asking, why are we using these turbines? Why are we not using solar panels? And while some people did admit that in hindsight, it would have been better to use solar panels or even some wind, the general consensus was that we don't have time to worry about this. We have a telescope to run, and we have to use the easiest solution because that's not our job to worry about climate change. And I became a little frustrated with that. And actually, that kind of sparked my interest a little bit more. I started questioning our own practices, how we use our resources, how we use water. I know other colleagues were doing the same. And I became a little more environmentally conscious. I wanted to study basically a little bit better. And so this led me to study and try and understand a bit better cause and effect and where we headed as a society with our CO2 emission and what's happening. I am not going to go into the science of climate change here. I think Gina also did a wonderful job talking about the different status of different always interfaces. But it suffices to say that I got myself interested and worried enough, and I realized that the more I learned, the more I realized this was my very problem, even though I was doing astronomy. I wonder, maybe being a scientist also gave me the tool to understand the data and put them in a bigger context, understand the facts a little bit better or faster. But I was a little frustrated also looking at the news very often when people talk about climate and whether or not there is a consensus among scientists and whether or not climate scientists agree or not. And this is kind of used a lot. And once you start looking into the data itself without opinions, or listen to experts talk about the data and what's happening, it's clear there's a complete consensus that all of this it's not up to discussion whether or not it's happening. And it became clear that things are looking bad, or to paraphrase Captain Maffey, we're actually sitting on a poop deck. And in case you're wondering whether is the sun warming the Earth, the answer is no, it's not. This is known already. This is just a graph showing the temperatures of solar activity over 11-year average. And if you look at the actual temperature on Earth, while there could be some correlation, there was correlation in the past, this is definitely off, and carbon dioxide is to blame here. How about moving to another planet? Well, one thing astronomers do know is that the Earth is actually pretty cool, and it probably is the best planet we have in the universe right now. And I don't think there's any other place to go to in the immediate future. So we're better off taking care of this one. Science is an integral part of humanity, and to think of ourselves as not having to worry about climate change or these sort of issues like that don't belong to us is just wrong. So I considered it an ethical duty to stand with the climate scientists, to show support and solidarity, and support the notion that are all survival in danger. We should also improve our own work practices and help spread the word. So in 2019 in Lyon, we started discussing this among colleagues, and actually I discussed this with everyone. And I found so many like-minded and wonderful and resourceful colleagues, and we decided to build or to fund Astronomers for Future. Here's a picture of me and Gina having dinner together. It was a very memorable dinner, actually, and also other founding members. Of course, here's Gina with Giuseppe Cimò, presenting the EVN symposium, which is also like the Event Horizon Telescope. And at the bottom is us funding, of course. Leaderboard is also highly involved. This is us sort of signing our agreement. Shortly thereafter, we discovered there was a very similar group called Astronomers for Planet Earth in the US. It was bigger than ours. We decided to join forces with them, and we merged into Astronomers for Planet Earth as one big collaboration. Our aim is very, very simple: to, first of all, pledge to lower emission in our own environment. That means less flying, taking care of our buildings, our heating, how we commute, and of course, how much is used for supercomputers. We want to help spread the word. Talking about climate change is very powerful to actually normalize this topic and help people do something about it. We're also involved in outreach events and also talk about climate change within universities, and also live ourselves more environmentally friendly lives and talk to friends about it. But we also want to offer solutions, not just raise the problem. Here at Leiden, We also recently started a sustainability committee. We're looking to ways to reduce our own carbon footprint, obviously fly less or not at all. Again, heating supercomputers, share vegetarian recipes, etc. We want to educate, include climate change lectures, also into maybe some astronomy lectures. And we also created a group called Inspire Society, where we're planning to create a number of outreach events linking astronomy and climate. Some of them are going to take place in the old observatory, some others maybe in a museum. So it's going to be interesting and hopefully fun events. And by the way, we are looking for volunteers. If you would like to be part of this, please contact us. Especially if you speak Dutch, you know, we can be multilingual. Let me get back to the black hole and see how that can help with our climate. This is the image of a black hole. Actually, this is a hyped up and better image that came out a few weeks ago where we also see polarization. I would like to share with you what it took to take the picture of the black hole. I think I told you that it took to make a telescope that is bigger, as big as the Earth. But the truth is that what it really took was for all these people, every one of these people, to actually work together. It was the result of teamwork. It may look like this is a perfect team and people got along, but it's not always been the case. This team went a long way. It used to be many different people actually competing. And over time, it became clear that this was such a big goal that we had to work together, you know, get rid of our boundaries and actually work as if we are one big team with no differences. And the Event Horizon Telescope really, you know, come a long way into doing that. And it's not been easy, but they managed. I think, well, there's 327 members, 13 stakeholders, 83 institutions, and 19 countries. It was really not difficult, not easy. And by the way, they still have a lot of questions to answer. For example, one question is how we get from the black hole to the jets that I talked to you about before. I didn't tell you. And this is still a kind of a mystery. Also, we're waiting for the image of black hole at the center of our galaxy. So there's still work to do for them. But I think we can learn from them. And one thing that we will need to resolve our climate crisis on Earth is also that we work together as one Earth, as one planet, that we drop our boundaries, our personal interests, the interests of our countries somehow, and we work together. And you can also help by talking about it. All of us can. We kind of discovered how powerful it was to talk to each other. Finally, just a comment about why am I talking about climate change during the COVID pandemic? Don't we have big enough problems now? Maybe this is for later. And you've seen this cartoon before, I'm sure, and this is really true. The COVID crisis has actually shown that life can change very quickly, and it can stay, those changes can stay with us for a very long time. So we should really worry about climate change right now, because this is still the time we can do something about it. It will be too late at some point. In fact, the COVID pandemic is quite interesting because global emission has gone down, of CO2 has gone down thanks to the pandemic, because there's less flying and less, less business. The decrease in CO2 emissions has gone down by about 8.8% globally in the same period of 2020 compared to 2019. And some papers break down in different categories. This is a huge shift down. However, I do find it amazing that even though we're all at home doing nothing, we've only gone down 8% or 10% when we need to go down 100% in the foreseeable future. So this is the CO2 emission over time. And as you can see, it's gone down in the recent future. However, if we don't take a sustainable recovery and we think about this now, we're in danger of making CO2 emission go up again from what we left. So the time to act definitely is now. This is my take-home message. First of all, as you know, black holes exist, but still hold many mysteries. So stay tuned for more beautiful images and answers. My second take-home message is that we all need to play our part and work together to resolve this climate crisis. We need policies, big policy changes. but each of us can and must contribute. So please go home, talk about it, talk with your friends and colleagues, and let us normalize this topic. And I'm gonna leave you, I'm done, I'm gonna leave you with my favorite cartoon. I'm done.
Thank you, Violette. That was an excellent talk and very thought-provoking. And also, I would say I really liked how you kind of merged together black hole and environment. Yeah, that was great. And as we already have some raised hands and questions from YouTube, but just as a reminder, if anyone from the audience want to ask a question, you can type it in the chat if you don't want to ask it yourself, or you can raise your hand and you'll be given your chance to ask it yourself. Or if you're viewing us on YouTube, you can ask your questions there as well. So before I think I move on to the next questions from the audience, I have actually one question myself. That is, you mentioned that you are looking for volunteers, especially people who can who are Dutch speakers, yeah, for your outreach activities. So my question is that only open for astronomers? And the second is, how can they contact you if somebody is interested?
Yeah, so in principle, yeah, that is actually a good question, whether it's only for astronomers. In principle, I'm inviting astronomers openly who can speak Dutch. However, I think if non-astronomers are interested to contribute, we can actually definitely work together. One of the things we're looking into right now is to work with schools. So if you have your children are in a local school, you could contact us as well, and we're trying to set up some programs. We're starting small, and then we're hoping to make them bigger over time. So yeah, please contact me even if you're not an astronomer, and I can type the email here in this chat.
Thank you. So our first question actually came from YouTube audience, Andrew Reitner. And his question is, are you aware of any scientific disciplines that are dragging their feet on the climate issue, or is there a general consensus?
Sorry, whether dragging their feet, and what meaning not tackling it or do not believe in it?
I think that's what he meant, like they are not believing that we need to face this now. And
yeah, okay. I don't remember ever talking to any other scientist who questioned climate change. I believe there is consensus, at least among people I've come across. I'm pretty sure there is consensus, even to those I haven't talked to. But yeah, I haven't come across that.
Yeah, it would be a different issue if we need to convince scientists first that look at this. Yeah, hopefully. So here from our audience in Zoom, we have a raised hand from Tuan Ant, and I will ask you to unmute now. You should be able to speak now and ask your question.
Okay, Michael, thank you for the talk. My questions are about the.
I cannot hear you clearly. Can you?
You can't hear me clearly. Oh, give me a second, please.
How about now? Maybe
better, yeah,
right.
Much better.
Yes, my question for you is the ALMA telescope. I guess it was built quite a long time ago, and perhaps that is an excuse for them not having the technology of solar powered generation and storage to use solar power for such a, what I imagine is energy intensive application. So I guess, first of all, is that the excuse that they give? And second of all, is there any plan to move away from the diesel and petrol or whatever they're using now? So do they acknowledge that that is a problem, and are they trying to move away from that, or is that just?
Yeah, so yeah, that's a good question. Those are two very good questions. The first one about was built a long time ago. It wasn't that long. It was actually built around 10 years ago, but older, and they went with the original plans, which were made in a time where solar was not as cheap as it is now, or even as widespread. And so they went with whatever is easiest at the time to build. They have excuses why they did that. It wasn't lack of interest. But at some point, they could have sort of the handbrake and try.
Oh, Violette, you're breaking up a little bit,
Oh,
right?
sorry. Can you hear me?
Yes.
Can you hear me now? Okay, sorry, because I was. Yeah, so I do think there was a bit of a cultural shift that needs to happen in the sense of prioritizing where you put your resources. ALMA is a big telescope, 66 antennas. There's always many fires, and so I know that people tend, like we do in many lives, we need to tend to concentrate our efforts on immediate issues, and this was not an immediate issue. So in the 10 years I was there, I must have talked about solar panels like a broken record to many directors that came and went. And I know the interest has been rising. I don't think they're going to take off the turbines. They're too far already invested in that to actually undo them. And I'm sorry to say that, but I don't see them happening. The best solution we might have is to join the grid, which is off. So the general grid in Chile, some of it being renewable. Actually, wind is very prominent in this area. And we've been trying now to push for the grid at this point, not any more solar panels. So that might happen.
Thank you. Cheers.
Cheers.
Thank you, Violette. And I think Leo just amended to your answer that, but at least they got connected to the gas grid, so no longer they don't require to transport the oil to the remote site. So that's
who did? Alma did?
I suppose that's what he meant, because there is actually another question from the audience by Ishan Mishra that it was the same. Has Alma started using solar panels yet? So it was it was Alma then.
Yeah, I wasn't aware that Alma. Maybe he's referring to Paranal. I wasn't aware that Alma was connected to the gas grid, but yeah, thank you, Leo. I'll look into that. Alma did. Okay.
It's great to see that they're starting to understand that it's not really.
Yeah, well, they're still burning it. It's just don't have to have trucks bring it up all the time.
Yeah. So while I think that was the last question, and we can maybe wait a little more if anybody has any more questions, but I would like to ask you that you mentioned the imaging of black holes, that currently we're also waiting for a lot more data. So we are also waiting for the image of our own galaxy's black hole. So when can we see it? Can you tell us about it?
Yeah, so this is actually a hot topic. When is the Sagittarius A star image going to come out? And there's been quite a bit of progress, and papers are being written, and we'll hopefully soon. I cannot say when exactly because it depends, but please stay tuned because there's exciting news coming out hopefully this year. Well, for sure by the end of the year.
Yeah, definitely. So I don't see any more raised hands or any more questions. So I think that's the end of our question answer for now. Exciting news to look forward to in terms of black hole science, and also hopefully more sustainable practices for astronomy institutes across the world. So thank you, Violette, once again. And Wendy will conclude today's session now.
Great, thank you again. And it was actually sort of on this topic, I just saw recently the South African Large Telescope sharing images online of their new solar farm, which is some good news. I will just quickly share my screen to do the final thanks. So yes, if you're interested in joining us next month, we have an event on the 31st of May. It will be about the history of astrology and its relevance to astronomy. So stay tuned for that next month. A big thank you to both our speakers tonight. Very interesting talks on a very hot topic. We will get our beer glasses to you as a thank you for coming. And as usual, a big thank you to everybody in our team who helps put together these events. So that's all for tonight. Thank you everybody for joining us. I hope you've enjoyed the games tonight and the slightly different format. So thanks and good night.
Thanks for all of you for organizing.